So today we start talking about compounds and how they are combined, chemical formulas and compounds, chemical reactions. This is one of my favorite chapters because we'll learn how to write chemical formulas, we'll learn how to read the names of chemical formulas, we'll learn how to balance chemical equations, and we'll learn what type of chemical reactions actually occur. So it's a very cool chapter to deal with. So today we want to look at an important part of chemical formulas, and that is oxidation numbers. All right, oxidation numbers is basically the number of electrons that a bonded atom would have to gain or lose to return to its neutral state. Number of electrons a bonded atom would have to gain or lose to return to its neutral state. So we're going to keep that definition in mind when we look at our oxidation number rules. And that's the very first part of being able to write a chemical formula well, by knowing our oxidation rules. So, our rules. And again, we're going to learn the rules and we're going to apply those rules when we try to figure out oxidation numbers. Oxidation number of a pure element is 0. That means an element that has not been bonded with anything. So if I ask you, what is the oxidation number of sodium? Well, it's already at its natural state, so it doesn't have to gain or lose anything, so it's 0. O2, element. All right, it's always diatomic, right? So the oxidation number of O of oxygen here is 0, because it's a pure element. If we had argon, it's just an element, so the oxidation number of that element is 0. So of a pure element, the oxidation number is 0. Oxidation rules. Oxidation number of an ion is equal to its charge. Is equal to its charge. So the iron ion, Fe2+, oxidation number is +2. The chlorine ion, Cl negative, oxidation number is -1. If you notice the distinction between an oxidation number and a charge. Oxidation number, the sign goes in front. The charge, the sign goes at the end. Carbon atom, or oxidation number would equal +4. An ion is equal to its charge. So when I look at this, NaCl, is this ionic, covalent, or metallic?
That's ionic.
Ionic, made up of ions, correct? The sodium ion would be Na. What happened to the electrons? Transferred over to the chlorine, so the Na is plus, and the Cl is negative. So Na has an oxidation number of +1, and Cl has an oxidation number of -1. Alright? Rule number 3 is divided up in a number of parts. Alkali metals. This rule and this rule kind of overlaps because alkali metals are always going to be an ion, right? And it's always going to be the charge of their valence electrons, always a +1. Alkali metals always has an oxidation number of +1. So alkaline earth metals always have a +2 because they're always going to have, they have 2 valence electrons, they're always going to lose them. My halogens when bonded to metals will always have a -1. Hydrogen when bonded to metals would be a -1. When bonded to nonmetals would be a +1. And again, remember, hydrogen has how many valence electrons? And it only wants to have how many? 2. So you're either going to lose 1 or gain 1. So usually when it bonds with metals, it will gain. So it will have a -1. When it bonds to nonmetals, it will lose. So therefore it will have a +1. So just knowing what happens to the electrons will help you with some of these rules. Oxygen, the second most electronegative element, always a -2, except when bonded to itself or fluorine. Remember, fluorine is a bully, very highly electronegative. Fluorine will always take oxygen, so when it's bonded with fluorine, it's going to have a positive one and not a negative one. And those are your special ones for Rule 3. Group 1A metals, always a +1. Group 2A metals, always +2. Halogens, group 7A, is always a -1 when bonded to metals. Alright, non-metals will be different. Hydrogen, when bonded to metals, is -1. When bonded to non-metals, is +1. And oxygen is always -2. Always -2. the sum of all the oxidation numbers of a neutral compound is always 0. Say for instance, we had the example in ACl. In A was +1, Cl was -1. Those two together would add up to equal 0. Let's look at MgCl2. My Mg, which is the alkaline earth metal, has an oxidation number of +2. Chlorine, which is a halogen bonded to a metal, will have an oxidation number of -1. We have 2 of them, so that's -2 and 2 makes 0. Okay? So again, when I'm looking for oxidation numbers, I'm looking for the oxidation number of the single atom, not the group of atoms. The common mistake is Cl, its oxidation number is -2. No, that's incorrect. Cl has an oxidation of -1, but you do have 2 of them for a sum of -2. When you add to magnesium, it is a +2 equals 0. The sum of oxidation numbers always equal 0 if it's a neutral atom or neutral compound. Yes, sir?
Neutral compounds are ionic compounds?
Well, all your compounds are going to be neutral, because all your compounds would not have a charge. Now your polyatomic ions, now they have a charge. So that's why I said neutral compound. So just like this is a ionic compound, but it's neutral, because the charges cancel each other out. Alright? H2O. Well, we got hydrogen, and we got oxygen. Well, oxygen always has an oxidation number of what?
-2.
Hydrogen, when bonded to a nonmetal, has an oxidation number of what? How many hydrogen you have? You got 2 of them, so 2 plus 1s and a -2, does that equal 0?
Yes.
Yes. So this is part of the stuff that we're going to be doing with oxidation numbers. Rule number 5. Sum of the oxidation numbers of polyatomic ions is equal to its charge. It's equal to its charge. So take for instance, sulfate, SO4, 2 negative. All the oxidation numbers should add up to equal
4, 2 negative. No, 2 negative.
Alright, -2. Alright, the oxidation number of this ion in itself would be oxidation number of this ion itself would be what? Go back to rule number 2. Oxidation number of ions are going to be equal to its charge. So SO4 would have an oxidation number of -2. So let's look at this. I know oxygen has a -2 oxidation number when bonded to anything except itself and fluorine. So oxygen here would have a -2. Well, the one in question would be sulfur. Well, sulfur, the whole sum must equal how much?
8.
So the whole thing, right here, the oxidation number of the whole thing must equal what?
2 negative.
-2. Well, oxygen is -2, I have how many of them?
4.
So that total of?
So sulfate has to be +6.
Sulfur would have to be +6. Yeah, you got a question?
Yeah, I'm kind of confused. So, you just take it and then, like, whatever's left over to make it equal 0 is just the number you put in.
But in this case here, I'm gonna put in whatever's gonna make it equal to -2. Right? Because oxygen always gonna be -2. So I know that for sure. Sulfur is the one that that will vary. So because sulfur varies, I know the whole thing must equal -2.
Okay.
So if oxygen, which I have 4 of them, equals -8, and it must equal -2, that means sulfur has to be
6.
+6.
Okay.
So they must always equal. Alright, so what are we going to be doing in class or on your worksheets and in your homework? You're going to tell me the oxidation number of each element. How many elements do I have?
3.
I got Na, I got P, and I got O. Alright, which ones do I know for sure?
Na.
Na, which will be
Double plus 1 plus.
+1. Correct. What else do I know for sure?
Oxygen and -2.
Oxygen is -2. Well, how many oxygen do I have?
4.
So there's -8, correct? How many sodium do I have?
You got 3.
So that's going to be what?
3.
+3. So that means phosphorus must be
5. Plus 5.
+5. Yes, ma'am.
Now I'm confused on that one. How did you figure out +5?
Because it has
All right,
to base
hold up, hold up.
oxidation number.
Alright? All of them must equal 0, correct?
Okay, so if there's no oxidation number there already, it's gonna be 0.
Well, no, because rule 4, sum of oxidation numbers always equals 0. So when you add them all together, it's going to equal 0. So if I know sodium is +1, and I have 3 of them, that's a total of +3. Oxygen is -2, and I have 4 of them, that is -8. -8 and +3 is, and where do I add the -5 to get 0? +5. Okay? Trying to think of one I want to do. All right, N2O4. What elements do I have?
Nitrogen and oxygen.
Nitrogen and oxygen. Which one do I know for sure?
Oxygen.
Which is?
-2.
All right, don't have a rule for nitrogen, so how many oxygen do I have? All right, I have 4 of them, so that makes -8. So that means I got 2 nitrogen must add up to equal,
Plus 4.
the 2 nitrogen must add up to equal 8, so each one is going to be
Plus 4.
+4. Here's my oxidation number. All right, NF3. We got NF. Which one do I know for sure? Fluorine is going to be -1. All right, is that halogen is the most electronegative? It's always going to steal the electron, so therefore it's going to be -1 always. So nitrogen must be a +3. I get 3 fluorine, that's -3. So what do I add -3 to get? 0 plus 3. These are my oxidation numbers. All right, any questions on oxidation rules? All right, so we're gonna stop there. Talk about naming compounds tomorrow. All right, chapter 19 term to do Monday, next Monday. Make sure you have a quiz. And your section review questions 19